Good morning, my name is Elena and today I will present you a problem in a greenhouse. The problem is a hot object placed in the open air will gradually cool down. We can slow down this process by containing the object in a greenhouse. Compare different mechanisms of heat loss by the object and explain how the presence of a greenhouse affects them. So I assume that by radiation heat loss will be the slowest. First I need to explain what is heat and how heat can be transferred. So on this picture we have three ways. It is convection, conduction and radiation. Basically heat is energy in transit, so it means it can be transferred. When an object is losing its energy by radiation, it means that it emits electromagnetic waves, and by emitting waves it loses its own energy. By conduction, it's basically losing heat by touch, following my second law of thermodynamics. It means that object with a higher temperature will give its own energy and heat to object with a lower temperature, until they both have the same temperature. And convection is caused by movement of particles. The particles are moving crazy, they're crushing an object, and by crush, object is losing its energy. And here is the example for better understanding. So this is one of my experiment. I had a glass bell. Inside I put the hot object. Before measurement I put the object on a hot plate until I get the right temperature. And glass bell was connected with a vacuum pump. And here are sensors which are measuring temperature. And for measurement with conduction I used aluminum plate. And I've been done my measurements in a room with closed doors and closed windows. And my biggest mistake is that I didn't repeat my measurements. Here are results. This is a graph where it is shown how fast object is cooling with radiation, convection, and conduction. And we can see that radiation is the fastest, while conduction is the slowest. Here's compared convection in a glass bell and with convection in air. And we can see that convection in a bell is, heat loss in a bell is slower than in air. So I conclude that glass bell, greenhouse, is like a closed box where temperature is where heat is transferred, and I can conclude that glass some races can pass through glass, and some of them can't, and that's why a bell is like a box that we can somehow. I want to explain that we have a bell and a hot object By radiation it emits waves, and the waves can't pass through the glass, so they stay in a band, and the air and the glass are heating, and by conduction and object we have heat loss, and we have heating the aluminum plate, and we have also radiation. And by convection we heat the air inside, so it means that we can cool it by air and by plate and by radiation. And this is how greenhouse works. That's it.
So, opponent has 3 minutes of clarifying questions.
Could you go to the first graph? Okay. Why did you choose 20 minutes of time?
Because after 20 minutes I have the same temperature of object.
Okay. Could you go to the slide before that? Okay, so why did you choose aluminum plate, and what is actually the vacuum pump for? I didn't catch you on that.
Vacuum pump is for making vacuum. And I chose aluminum plate because it's aluminum, and for calculation that I will done later, I know the constants and all that stuff, and I had aluminum plate.
Okay, the next phase is the preparation of the opponent. 3 minutes.
The experiment that you had was good, just more repetitions and that it would be great. And your conclusion was also good. I would like to ask you, why do you think in the first that the radiation would be the slowest?
Because by conduction and convection, it's caused by pressure particles or by touch, and I think that by radiation it would be the slowest, because there's no touch, there's no convection, there's no air.
Okay, so how did you choose the setup that you used in the experiment?
What?
The setup that you used in the experiment, how did you choose it? Why did you choose the setup that you had actually?
Because I wanted to divide the parameters.
Okay. The solution of the problem, yeah, I said a small number of repetitions, but the solution was well thought out, and you had some measurements, and you made good graphs. Just if you could fit some line to connect them all. So, discussion, what was the type of glass that you used in the experiment? Do you know?
Plastic glass.
Okay, so what would happen with different kinds of glass?
I think that there's no much difference. I mean, it depends of thickness of glass.
Okay, so do you think that this experiment represents the natural glasshouse effect correctly?
Yes.
And what parameters could you change to improve the heat loss?
I changed the way the heat is transferred.
But some other ones do you think that could improve the heat loss?
Yes. I would definitely set some fan and try to imitate conduction with fan and with different velocities.
Okay, so how do you think it would change by velocities?
The heat transfer would be fastest movement of particles.
Okay.
Bigger velocity.
And in conclusion, your presentation was short, but it was well thought. Good presentation. Your problem was solved very well, even though you had not the best measurements and small number of repetitions, which you could improve in the future. And that would be it.
The next phase is clarifying questions by the reviewer. Andrej. You can now ask the clarifying questions. Okay. Yes. Then is the preparation and then it's the statement.
Okay, so my question is, what type do they have to be?
You need to ask if you are asking the opponent or the presenter. And
Okay, so I have a question for the presenter. Do you know some practical uses for this effect?
Yes, in garden.
Well, is that it, or is there other fields this can be used?
Can be used in astronomy, maybe.
Okay, where exactly?
In universe we don't have air and we don't have some objects to conduct the heat. So objects in universe are heated only by radiation. And maybe Earth's atmosphere.
Okay. Do you have more question or is that it? That's it.
okay, you have 2 minutes to prepare.
For example, the question about the aluminum foil. The presenter's presentation was a bit short, but she had a lot of things to say, and I really appreciate that. And I think that the opponent really picked the questions really well, and that's it. Really, I don't have many more things to say.
Okay. Then there is a statement by the opponent.
Okay, so I would like to thank the reviewer for saying that our presentations were both good, and I would like to thank the presenter for their presentation of this problem, which was quite well done. And that's it.
Okay, the reporter.
Okay, I have to say to reviewer, thank you, but I would like if you give me some pros and cons of my presentation. And I think the opponent could give better questions, but it's still okay. Thank you.
Okay, now are the questions by the jury. Lauren, do you have questions?
Yeah, sure. Could you show me the graphs you have in the presentation? Could you explain what we are seeing now?
So it is changing temperature in time. This line presents conduction, this one convection, and this black dots radiation.
Okay, how did you check, how did you experimented with the conduction? Where did you measure the temperature?
I measured on plate and on object, but here is shown temperature of object.
Could you go back on this picture with this glass? Yes, glass bell. Where did you check for the convection?
I put the object here and the sensor on it, and I measured the temperature here on plate and on the top of object.
But all this was in vacuum, right?
Yes.
And then how did you check the convection?
Convection, sorry, I mean for conduction. No, I put air inside.
Okay.
And then I was measuring. I put the air inside and I had a glass bell, and outside was, of course, air. I mean, room.
Okay. What was your conclusion? What method is? What kind of heat transfer is fastest?
Conduction.
Okay, and do you expect that also for the cooling?
What?
Do you expect that conduction is also the fastest way to cool the object?
Yes.
Okay.
You're done?
Yeah.
Okay, can you go back to the hypothesis? Why is it relevant to this problem?
What?
So, how is your hypothesis relevant to the greenhouse effect? The effect of having a greenhouse presence?
Well,
It is, but how?
well, I mean that if I put some hot object in greenhouse, it will cool the fastest if I put it on some plate in greenhouse. So that's what I thought.
And how does just the greenhouse influences? And if you have some floor and you put an object on it, and you just look how is the heat loss different when you don't have a greenhouse and you have a greenhouse. So what?
When I have a greenhouse, the rays of radiation are staying in greenhouse, and the whole system is heating. And when I don't have greenhouse, I have three types of, I mean at least two types of heat transfer.
You have those kind of heat transfer in greenhouse too, but the thing is that the system is heating up also.
Yes, but
Because
in greenhouse more than in air.
You have air in greenhouse also. But the amount of air is in the greenhouse. And
The volume is different.
yes, and it doesn't give heat through convection to the rest of the air outside of the greenhouse.
Yes.
Okay. Can you quantify temperature transfers?
Yes, by formulas that I don't know right now.
Okay, why didn't you use them?
Because I wanted to calculate it with some special formula, and I didn't have enough time to understand it at all. So that's
Okay,
the
can you
idea for
go to
improvement.
the first graph? Okay. So you're telling us that radiation is temperature, or what's the radiation? Is it
Radiation is
what is heat? Is it temperature or is it energy?
energy.
Okay, and you are telling us here on the legend that radiation is temperature. Okay. So how did you isolate every of the other heat transfer when you used radiation, convection, and conduction?
With radiation, I isolated by putting object in a vacuum, and
So
it's
what kind of heat transfer does a vacuum eliminate?
convection.
Okay.
And I put it in the middle of a well to
Eliminate conduction.
die.
Okay.
Yes.
And how did you measure only convection? So how did you eliminate the radiation?
With aluminum foil. I planned to do that, but I didn't.
So here you had radiation and convection,
Yes.
and in third conduction you had radiation and conduction.
Yes.
Okay. You should have a picture or schematics for every type of measurements, not all in one picture. Also, do you have a picture of setup, or are these just random numbers? What you think?
I have, but I didn't put it because it looks catastrophic.
Yeah, you should put it even if it's catastrophic.
Okay.
Okay. For opponent, there is no question while giving a statement. So clarifying questions are first, then you have pause for preparation, and then you have a statement. So 4 minutes you are talking about what the reporter did and what are its cons and pros, and then you state what you are going to discuss in discussion, and then you move on to the discussion.
Okay.
You didn't use the whole time. And also, do we want to improve the heat loss or to reduce the heat loss?
Reduce the heat loss.
Okay, so don't say that you want to, how would you
Yeah.
improve,
Okay.
but how would you reduce the heat loss?
Time up.
We have been thinking that.
Okay. Just saying.
And you didn't use the half of the time you were given. Also, Elena, reviewer first ask questions related to discussion. So you want to take some conclusions from the discussion. You want to conclude, okay, she measured the radiation and convection. The opponent thinks that is okay, and similar. To all question, first for the reporter, is the problem of atmosphere, so a greenhouse effect, the same as the greenhouse you are currently investigating?
Yes.
Well, not really. You don't have a bias on the Earth atmosphere, that's first.
But system is similar.
And there is.
There's radiation from sun outside.
Yes, but what happens to the light that goes through the atmosphere also?
It's going on Earth and back.
Yes, some goes back, and here you don't have that much back, except for the glass. And you didn't say nothing about the what the glass does to radiation as light. Luka, do you think it's the same problem, greenhouse effect, and this problem?
Well, not completely the same, but it's similar.
Okay, but it has differences.
Yeah.
And also, while a reviewer is giving a statement, you should stand up and give it. There also, Luka, when you are giving a statement or asking questions, giving a statement, you shouldn't be turned to the board. You should be turned to the reporter and to the rest of the jury and all other teams. Okay, do you have questions? No. Anna, do you have?
Well, I agree with Todić because I would just said that it wasn't very clear how to distinguish between these three processes, so we should work more maybe on that. And the last statement about that drawing of a greenhouse, you just said that this is how it works. It wasn't clear from the picture how it will
So I think that as you are from Zagreb, you will give the report again with Grg.